Alright, so let's start up again, taking a look at the two practice problems, 33.15 and 33.16. Alright, so the first one, you're given that there's an opaque object 15 centimeters from the point source of light, and that object has a height of 6 centimeters. You're also told that there's a distance of 40 centimeters from the opaque object to the screen where the shadow is formed. However, the 40 centimeters is not the distance of the shadow from the point source. In order to get that, you have to add the 15 and the 40. So the distance of the shadow from the point source then would be 55 centimeters. So here's our basic equation. The proportion says height of the object compared to the distance of the object equals the height of the shadow compared to the distance of the shadow. And we're asked to calculate the height of the shadow that results from the given information. So use algebra, solve for height of the shadow. So that, again, you multiply both sides of the equation by distance of the shadow. So you'll get something like this. If you have these terms in different order, it doesn't matter with multiplying. The order in which you multiply is not an issue. So then plug in the information. Distance of the shadow we said was 55 centimeters. The height of the object was given as 6 centimeters. And the distance of the object is 15 centimeters. 2 of the centimeter units cancel out and you're left with centimeters. And that will give you an answer of 22 centimeters. So if you step back and look at that, does that make sense? It's a reasonable answer. The sketch wasn't done really well. But definitely you can tell from the sketch that the height of the shadow is much, much bigger than the actual height of the object. So the 22 centimeters is a reasonable answer. And as we've done in other problems, I would highly recommend that you track your units to make sure that the units work out while you're doing the problem. Here's the next problem, number 16. So you're given that you have a plate 80 millimeters in diameter. That is our opaque object. And the height of the shadow is given as 400 millimeters. And you're asked to solve for the distance of the object from the point source if the shadow is formed at a distance of 2 meters from the point source of light. So you see that we have mixed units. You could elect at this point just to do a conversion to make sure we're dealing with consistent units. So we have 1,000 millimeters in a meter, so we can already, if you wanted to, you could change the 2 meters into millimeters. So now we have all the given information in the same units. So we're solving for the distance of the object. Could we make a wild guess at this point? Maybe before solving it, what would be a reasonable answer? Now again, this is not really drawn to scale. Probably better, if we were to draw it to scale, we could make an educated guess. height of the object is 1/5 the height of the shadow. So if we could draw it that way, maybe it would be more like that. Something like that. So if the distance of the shadow is 2,000 millimeters, what might be the distance of the object? It'll be quite a bit less, maybe 300 or 400 or 500 millimeters, something like that. All right, so we're solving for distance of the object, so you can manipulate the equation to solve for distance of the object. This one's a little trickier. What you're solving for is down in the denominator here. I'm not trying to force you into any particular method, but you need to have algebra skills that work. I mean, one thing you could do to make it visually look better is, remember in algebra, when you do something to one side of the equation, you have to do the same thing to the other side, and you still have an equation. So what you could do is you could invert both sides of the equation. Distance of the object compared to height of the object is to distance of the shadow compared to the height of the shadow. We're solving for distance of the object. All you have to do now is multiply both sides of the equation by height of the object, and you're done. So that's one way. There's probably lots of other different ways to do this. If you have another way you like that it worked, that's fine. So distance of the object then is equal distance of the shadow, which is the 2,000 millimeters, times the height of the object, which was the 80 millimeters, divided by the height of the shadow, which was the 400 millimeters. And two of the units cancel out, and you end up with an answer of 400 millimeters. And that does look like a reasonable answer. You would expect your answer to be a lot smaller than the distance of the shadow. Okay, I'll just leave that up there for a minute in case you're copying. All right, so I'm going to give you a couple things to do over the weekend. Okay, so you'll see from the new schedule that we will be starting Chapter 34, Reflection and Mirrors, on Tuesday. But also, before we do that, we're going to do an in-class demonstration on shadows. So this will be the first in-class demonstration we've done. So if you could, there's something that you can do to get ready for that, so we're ready to launch into it on Tuesday. So this is a in-class demo on shadows. So if you could turn in your workbook to page 31, and let me just give you a little bit of information. that. Okay. So this page has a sketch of the demonstration we're going to do. We're going to have a point source of light, and we're going to put an opaque object between the light and a screen and create a shadow. And you already have given information. The distance of the shadow is 1 meter. The other piece of information you need, so the idea of the demonstration is you're first going to do a calculation and make a prediction as to what's going to happen. So we're going to place a tennis ball between the point source of light and the screen, and that tennis ball is going to have a diameter of 6 centimeters, just a standard tennis ball. And then the other piece of information you need is what is the distance of the tennis ball from the point source of light. And we're going to place it at 35 centimeters. So you can go ahead and write that in on page 31. And then there's 2 predictions you're going to make. One is, given this information, what's the height of the shadow that will appear on the wall? And when we do the demo, we'll measure it. So do your calculation and predict that. And then the second prediction is predict. This is a different prediction. If we wanted to create a shadow that's 11 centimeters tall on the screen, where do we have to place the ball between the light source and the screen? So in this case, you'll be solving for distance of the object. Okay? So you're going to do both of those calculations, and then when we first get into class on Tuesday, I'm going to collect your prediction pages, and then we're going to perform the demonstration and record the results on the next page, 32. So that's one thing that you could do over the weekend to prepare. And the other one is that we should have here copies of the graded homework for chapter 33. So make sure you get a copy of that, and I'd like to have that graded homework turned in on Tuesday when you get back. And then after that we'll launch into chapter 34. All right, so that is it for today, and we'll see you Tuesday.